Hello and welcome to the class. In this video, I am going to discuss the theory of automata or theory of computation. Now, why theory is so important thing? Theory is actually the basis of the practical and the applications in the area of technology and the engineering. So here we will basically know why the theory of automata is important and what are the structure or the basic structure of automata. Now, if we're going to discuss the theory only, we'll check that theory provides concept to name what we observe and to explain relationships between the concepts. Theory allows us to explain what we see and to figure out how to bring about the change. And theory is a tool that enables us to identify problems and to plan a means for altering the situations. Theory also specify the principles for the actual thing. Now, what is theory of automata? If we come, we'll check that theory of automata is a theoretical branch of computer science and mathematics. It is basically used for computation, how the computation are done inside the computer, that we will know during this video. It is just the introductory part, and in the next videos we'll go into the details. So it is a study of abstract machines and the computation problems that can be solved using these machines. The abstract machine is called the automata. The main motivation behind developing the automata theory was to develop methods to describe and analyze the dynamic behavior of discrete systems. Automata, these words is coming from Greek language. In singular it is automaton and in plural it is automator. Now, if we can see this picture, it is a simple representation of an automaton or automator. Here we can see I1, I2, I3, these are the input, O1, O2, O3, these are the outputs, and Q1, Q2, Qn, these are the states of the machine. So an automaton consists of states and transitions. What is transition? That will come to this after some time. Now, what are the states? I will discuss this thing, just keep patience. Now, automata is the kind of machine which takes some strings and as input, and this input goes through a finite number of states and may enter in the final state. The output is related to either the state only or to both the input and the current state. It should be noted that at any instant of time the automaton is in some state. So suppose the current input is I1, the current out in state is Q1, that is the initial state, Qn is the final state actually. So Q1 is the initial state and I1 is the initial input. So based on that, maybe output 1 is generated. So this output may be only based on the current state Q1, and after that output O1 will be generated and the next state Q2 will be generated, or it can be depending on I1 and Q1 both, then Q2 and O1 will be generated. Now I am giving you one example. Suppose you are 30 years old and you want to save some money for the future. Maybe you are going for a pension scheme or retirement benefit scheme. So you will submit the money to the bank or any other organization, so that your money will be grown, right? So currently you are at Q1 and it is your age, that is 30. So you are belonging to the state Y, that means young. Maybe after 10 years you will become 40 years old, right? So here you will reach Q2, and Q2 means you will be in the middle aged person. So that will be middle age, will be the next state, and Q1 is the final state. At this final state you will become the senior citizen. Okay, senior citizen. Now as senior citizen is the final state, and at that time OQ will be the output. That means you can withdraw the money, that is OQ, and it will be the output. So you can see that time to time the output will be generated, as well as states can also be changed. And how these states will be changed depending on the state or current state, or depending on the input, we will check this in the next video. But we have to understand how the computer will understand our instruction. Now for that we need to know what is lag. What is lag? L stands for language, A stands for automata, and G stands for grammar. These three are the very basic things for the theory of computation or theory of automata. Now in this video we are going to discuss the detail regarding the language and how to construct the language. See, there are various languages like English, Bengali, Hindi, Tamil, Telugu, etc. Why these are used? These are used for interaction. Similarly, computer languages are also used for interaction. Interaction between whom? Interaction between the user and the computer. So how computer will understand our language, that we have to know. So before that, if we concentrate on the English language, the construction of the English language, in the very foundation area we can see there are letters A, B, C, D, etc. And using the letters, combining them, we'll get words. So words are the finite set or sequence of letters, right? Then what is sentence? Sentence is a set or sequence of words, or we can say it is a meaningful combination of words, right? See, if we say that I who am, is there any meaning? No, there is no meaning for that sentence, and that's why it will not be some meaningful sentence. But if we say who am I, it makes sense, right? It has a meaning. Similarly, for getting a meaningful thing, we need to construct the words in a way where the sequence of the A, B, C, D, etc. are organized, are done in an organized manner. And how we can do that? Using the grammar, or using the rules, or following the rules, we can build the words as well as the sentences. Similarly, for this formal language, we have symbols, alphabets, and strings, just like this: letters, words, and sentences. Now, what is symbols? Symbols are entity or individual objects which can be any letter, digit, or any special character. Letters like A, B, C, digits say 1, 2, 3, 4, 5, 6, etc., or special characters @ hash or ampersand, etc. So anything you can give input from the keyboard is treated as the symbol. And then what is an alphabet? Alphabet is a combination of symbols, or you can say technically that alphabets are finite set of symbols. Yes, it is finite set of symbols. That means the number of elements will be finite. Just for example, it can be and this is denoted by, just check, it is sigma. The sigma may be equals to AB. It is a set of A and B only. Okay, the two alphabets are, two letters are there. Capital letters can be there. Digits, because it is a combination of symbols. It is a set of finite number of symbols. Okay, digits can be this also, and it can have special characters too. Now, depending on this alphabet, we'll have the string. So it is a finite collection of symbols from the alphabet. The string is denoted by W. As for example, if the alphabet sigma is AB, then the various strings those can be generated from sigma are like AB, AA, AAA, BB, BBB, BA, ABA, ABAA, BA, etc. Okay, so any combination can be there. So this AB is a string, AA is a separate string, AAA is a separate string, BB separate string, and so on. Now, a string with zero occurrence of symbols is known as an empty string, and it is represented by epsilon. The number of symbols in a string W, here strings are represented by this W. So the number of symbols in a string W is called the length of a string, and it is denoted by mod W. So as for example, if you can see W, if W is 010, that means the string is 010. So the length of the string will be the number of symbols here. 0, 1, 0. So 3. That's why mod W is 3. So it is the length of the string. Length of the string is equals to the number of symbols present in that particular string. And how can we generate that string? Using the alphabet. It cannot be ABC. If the alphabet is contains only two characters A and B, then I mean the two symbols A and B, it cannot be A, B, C, D. The strings can be generated with A and B only. That you have to remember. Then what is language? Language is the collection of appropriate strings. Now just take an example, and before that one thing you should know: a language which is formed over an alphabet, it can be finite or infinite. How? Let us check. Suppose the alphabet is sigma and sigma is AB we have. So in this alphabet there are only two symbols, A and B. Now for the first example, suppose the language is L1. So L1 can be formed as set of strings of length 2. It is a language. Okay. So here set of string of length 2. By length 2 we can have, using this A and B, AA, BB, BA and BB. So these four strings can be there, right? Four strings can be there: AA, BB, BA, and it should be AA, BB, BA, and AB. Yes, it should be AB, right? So the four strings can be generated by this alphabet, and those are AA, BB, BA, and AB. So this language contains only 4 elements. Those are AA, BB, BA and AB. Okay, so this is the set. So L1 is equals to AA, BB, BA, AB. See, only 4 elements are there in this set and it is fixed. The number is fixed, and that is why it is called the finite language. But if we come to the second example, L2 equals to set of all strings started with A. See, if it is a string which starts with A, it can be A, it can be AA, it can be AAA, it can be ABB, it can be ABB, and there is no ending, because there can be many strings, infinite number of strings which is started with A. See the previous example, the length was given, so it is a finite number. Set of strings of length 2, so we can get a finite number of elements here. But in this case, the number of elements is not a finite number, it is infinite. And as this language L2 contains the infinite number of elements, that's why it is called infinite language. So a finite language will contain finite number of elements in that set, and an infinite language is containing the infinite number of elements in that particular set. I hope you have understood this thing, the concept of the language. Here if we come back, you can see it is symbols, then alphabets are formed using the symbols, and then length of symbols we have checked, and using the alphabet we have formed the language. Okay, if there is any question, you can comment in the comment section. For any query, I will try to answer. Thank you for watching.